What if I told you that a tiger's famous stripes don't just stop at its fur? They're actually engraved into its skin, hidden beneath the surface like a permanent tattoo. Picture a tiger moving silently through tall grass, its orange and black coat blending perfectly with the shadows. Those stripes are its signature, the mark of a predator built for stealth. But what you see is only half the story. Peel back that fur and you'll find something even more astonishing. The stripes are still there, etched directly into the skin. It's a biological marvel that raises so many questions. Why would a tiger need striped skin if it's covered in fur? How does this even happen? And what does it tell us about one of nature's most iconic designs? For centuries, hunters, biologists, and zookeepers have whispered about this phenomenon. Tigers, when shaved for medical procedures or studied after death, reveal a pattern on their skin that mirrors the stripes above. It's not a coincidence. It's written into their DNA, a blueprint that shapes them from the inside out. But to understand why this happens, we need to look deeper than the surface. We need to explore how a tiger becomes a tiger long before it ever grows its famous coat. Let's start with the basics. We often think of fur patterns as something superficial, like paint on a canvas. But in the animal kingdom, appearances are rarely that simple. A tiger's stripes aren't just decoration. They're a functional tool shaped by evolution over millions of years. In the dense forests and grasslands where tigers hunt, these stripes break up their outline, making them nearly invisible to prey. But here's the twist. That camouflage isn't just fur deep. It's skin deep too, and that changes everything. So how does this happen? The secret lies in embryonic development. Before a tiger cub is born, its skin and fur follicles form in sync, guided by the same genetic instructions. Special cells called melanocytes produce pigment, dark melanin for the black stripes, and lighter areas where pigment is sparse. But these cells don't act randomly. They follow a pre-written map, a kind of biological code that determines exactly where stripes will appear. That map is so precise that it marks the skin itself, creating permanent dark and light regions even before the fur grows in. It's like the skin is the template, and the fur is the final layer laid on top. Now, you might wonder, why would evolution bother with striped skin? If the fur already has stripes, what's the point of duplicating the pattern underneath? One theory points to functionality. Tigers don't just rely on their fur for camouflage, they also use their skin. In hot climates, tigers often swim or rest in shallow water. When their fur is wet or flattened, the underlying skin pattern could still help disrupt their shape, offering a backup form of concealment. But there's another, more fascinating reason: developmental efficiency. By encoding the stripe pattern directly into the skin, nature ensures perfect alignment between fur and skin from birth. There's no room for error. The follicles that produce dark or light hairs are rooted in corresponding dark or light patches of skin. This harmony reduces complexity during growth, making the system robust and reliable. But tigers aren't the only animals with patterns that go deeper than fur. Some dog breeds, like the Dalmatian, have spotted skin under their spotted coats. Even humans have a hidden map of sorts: freckles, birthmarks, and subtle pigment variations that follow underlying cellular distributions. What makes tigers unique is the boldness and consistency of their design. No two tigers have the same stripe pattern, each is as individual as a fingerprint. And that individuality is preserved not just in the fur, but in the skin below. It's a permanent identity, Written in biological ink, this discovery also reshapes how we think about animal adaptation. Stripes aren't just a visual trick, they're embedded in the animal's very structure. From the earliest stages of life, a tiger's body is preparing for its role as an apex predator. Every part of it, down to the skin, is optimized for survival. That includes resilience to injury. If a tiger is wounded and fur doesn't grow back, the striped skin beneath can still provide some degree of camouflage. It's a small detail, but in the wild, every advantage counts. What's even more remarkable is how this trait has persisted across time. Tigers have roamed the earth for over 2 million years, and throughout that history, their striped skin has been a constant. It's a testament to the power of evolutionary refinement, a design so effective that it's been preserved not only in appearance but in the very fabric of their bodies. Modern science allows us to appreciate this on a cellular level, but the wonder of it is timeless. The hidden stripes are a reminder that nature often holds its greatest secrets just below the surface, waiting to be uncovered. So the next time you see a tiger, whether in a documentary, a zoo, or your imagination, remember that what you're seeing is only the outer layer of a much deeper story. Beneath that majestic coat lies a living canvas, marked with the same beautiful, purposeful design. It's a connection between form and function, between the visible and the invisible, that makes the tiger one of the most perfectly adapted creatures on the planet. If you were amazed by this hidden side of tigers, which animal's secret should we explore next? Let me know in the comments, and don't forget to subscribe to Animal Fact Vault for more revelations from the wild.